So far we have tried understanding the algorithm and pseudocode behind the selection sorting algorithm, right? Now let's quickly write the selection sorting C++ implementation and let's validate the same thing. So for that, inside the sorting, whatever the sorting folder that we have created, inside this folder, let me just add one more new file called selection sort.cpp. Okay, here let me just minimize the side nav and let me just import the main C++ boilerplate code that we will be requiring for writing any of the C++ implementations. Along with that, let me just also include the vector header file so that we can use that as well while writing the selection sorting algorithm. So here what we will do is just like what we have done in the case of bubble sorting algorithm, we will write our own class called selection sort. Okay, here we will be adding one public method. Here we will be writing our own selection sorting function which will basically sort the given array of values in the ascending order. So the definition of the function is basically it needs to take the array of values and in the end it needs to return the array of values, right? So for that array of values representation we are using vector, right? So it will return the vector in which we have only integer values. Let's name the function as selection sorting, and this function will also take an array of values, and let's just say in the variable arr. Now we need to sort the values we have got inside this vector in the ascending order and we need to return that in the end. So as part of the selection sorting algorithm, if you remember the pseudocode that I have explained clearly, what we will be doing, first of all we will take a specific position and we will find the appropriate value for that specific position in the remaining part of the array and we will fill that position with that appropriate value. So for that, for finding that, first of all we need to find the appropriate position, right? For that, in the beginning what I will do is I will initialize one for loop starting from I0, and this loop needs to run for all the positions we have in the array, which is nothing but last index, which is nothing but the size of the array minus 1. In each and every step I need to move on to the next position. Now what we need to do, the position that we need to fill is I. Now we need to find the appropriate value for this ith position in the remaining part of the array. So when we need to find that appropriate value, we need to compare the value at this particular ith position with the remaining values we have in the array, right? So for that what I will do is let me just define one variable called current index, which is nothing but the position, which is nothing but the variable which holds the position of the value that is appropriate for this position I. In the beginning when we are getting started, the value at that ith index, it itself could be the perfect value, right? As a result, I am initializing this current index variable with I value. Now what we need to do, we need to run another for loop so that we can compare the value at this current index with the remaining values we have in the array so that we will be able to find the appropriate values position or index. For that, let me just define another for loop. Inside this for loop, let me just define a variable called j. Here I am starting this for loop from I plus 1th index, because till the ith index all the values are already sorted. There is no point of comparing those values. We only need to find the appropriate value in the remaining part of the array, which is nothing but from I plus 1th index till the very last index we have in the array. As a result, this jth loop also needs to run till the very last index, that is nothing but less than array of size, and in each and every step I just want to increment the position by 1. Okay, now what we need to do, we need to compare the value at this current index with the value at jth index. If at all, if we find any value that is available at this jth index, if it is smaller than the value at this current index, right, this is the appropriate value, because we are trying to sort the array in the ascending order, right? we need to find the minimum value. If at all, if we are trying to sort the array in the descending order, we need to find the larger value. Since we are writing in this function, we are writing the selection sorting algorithm for sorting the array in the ascending order, we need to find the appropriate minimum value. So for that, let me just compare the values at the current index. If at all, if the value at the current index is greater than the value at jth index, that means the value at jth index is smaller. So if it is smaller, the appropriate value could be the value at jth index. That's the reason why I will simply update the current index with j. Okay, once we are done with running this for loop, right, we would find the appropriate values position inside this current index variable. All we need to do is we need to move this we need to move the value at this current index to the ith position and the value at ith position to the current index, so that in the later comparison that value can go on to its appropriate position in the array of values. So once we are done with this for loop, right, we just need to swap that. For swapping, let me just create one temporary variable and let me just get the value at ith index, and after that let me just assign the value for the ith index with the value at the current position. Okay, current index, and sorry, it is ARRR. Okay, after this what we need to do, array of current index should be updated with the value of the temp, which basically had the value at ith index before updating. Okay, so that's all there is for selection sorting algorithm implementation for sorting the array in the ascending order. If you observe the logic that we have here, right, if we compare the same logic with the bubble sorting logic, in the case of bubble sorting logic, we were comparing the values. As soon as we compare the values, if the value, two adjacent values are not arranged in the proper position, order, we were basically swapping them then and there only. As a result, there were a lot of swapping operations involved. But in the case of selection sorting algorithm, we are just comparing and we are finding the appropriate values position, so that in the end we can only swap once. That's what we are doing here. As a result, we are eliminating all other swapping logics and we are only swapping once. Once we find the appropriate values position, we are simply moving that to the particular position that we are trying to fill in. Okay, so that is a small but major difference. As a result, it brings in the efficiency as it eliminates most of the swapping operations. Okay, once we are done with this logic, we need to return the array which is sorted, right? So we will simply return the array itself. If you observe the logic here, in the same input array of values that we have got, in the same variable itself we are trying to sort the array as well. So it is also one of the in place sorting algorithms like bubble sorting algorithm. Okay, here let me just add the semicolon here for the class closure. Now we need to call this selection sorting function from our main method and validate the same thing. So to call the selection sorting function, first of all we need to create the object of this selection sort, right? So let me just do selection sort ss. From this ss dot, let me do the selection sorting. To this we need to pass a vector of integer values. For that, let me just define vector of int. Let me just add ARRR. Let's just say the array of values that we want to sort are 12, minus 10, 1, 1, 3. Let's just say 190. Let's just assume these are the values that I want to sort in the ascending order. So after this, we need to pass this input array to the selection sorting function. In the end, this will basically sort the array and it will return back those vector of values, right? Let's just try to store it in another variable, result array. And to print it, let me just quickly write one more for loop, I less than result array dot size. and in each and every step let's move on to the next index, and in this process let's just print result array of the value at ith index, uh, and let's print the space. And once we are done with printing all the values in the result array, let's just add the end line. Okay, now let's quickly execute it. To execute this, I'm just clicking on this run button. Okay, if you observe here on the terminal, see we have compiled the selection sort file and we have executed that. As a result, the output that we have got is -10, 1, 3, 12 and 190, which is sorted in the ascending order. If at all, if you want to add couple of more values, let's just say -100, -90, 125, anything, any values you can add. You can simply either click on that run button or right click on the mouse and choose this run code option. Okay, see the same array of values are also sorted in the ascending order. Okay, if at all if we want to sort the given array of values in the descending order, let's just quickly make the changes in the function that we have implemented so that we will have the selection sorting algorithm in the descending sorting order as well, descending order sorting as well. So here let me just modify the function name to selection sorting descending order. Okay, so the entire logic will remain same. The only change that we need to do is modifying this comparison operation from greater than to less than. Why? Because in the case of descending order sorting, first of all we need to fill each and every position with the next greater value. As a result, the only change is modifying that greater than symbol to less than symbol. Okay, so let me just copy this function name and let me just, instead of calling selection sorting, let me just call the selection sorting descending order function. So this array of values needs to be sorted in the descending order. So if I just right click and choose run code, see the values that we have got on the console are sorted in the descending order. Okay, so you can add as many values as you want inside this array and you can execute the same thing based on your requirement, whether you want to sort the given array of values either in the ascending order or descending order. You can just call the specific function that we have here, selection sorting descending order, based on your requirement. Okay, so that's all for selection sorting algorithm for sorting the arrays in both ascending order and descending order. Okay, so that basically wraps up the selection sorting implementation. Thanks for watching this one. In the next video we will get started with the discussions of the insertion sorting algorithm.